Hello everyone, this is grade 6, module 6, lesson 10, problem set. For the lesson summary, we see that the data distribution can be described in terms of its center, spread, or shape. The center can be measured by the mean, the spread can be measured by the mean absolute deviation, and the dot plot shows the shape of the distribution. So those are all things that we're going to have involved in here. So for one, it says, draw a dot plot of the times that 5 students studied for a test if the mean time they studied was 2 hours and the mean absolute deviation was 0 hours. So I know that the mean was 2 hours. And if the mean absolute deviation was 0, it means none of the values were not 2, because there's no variability, meaning all of them are the exact same. Because if any of them had a difference, then my mean absolute deviation would be higher than 0. So anytime you have a mean absolute deviation of 0, it means the value of all of the points are the exact same. It's at the mean. So that's why I can draw 5 of them directly over 2, because that was the mean and there was 0 validity, or 0 variability. 2 says, suppose the times that 5 students studied for a test are as follows. We have Ari at 1.5, Ben at 2, Chloe at 2, Dylan at 2.5, and Emma at 2. Michelle said that the mean absolute deviation for this data set is 0 because the dot plot is balanced around 2. Without doing any calculations, do you agree with Michelle? Well, first off, I know that if the mean absolute deviation is 0, all of the data points, the 1.5, the 2, the 2, the 2.5, the 2, they would all be the same. So, no. Michelle's not correct because there's variability in the points. But there's something else that she messed up. The mean absolute deviation should be 0. What she is telling me is that the dot plot is balanced around 2. Well, she's telling me that the mean is 2. So there's my statement there to help out with that. Now, if we take a look down at 3, suppose the number of text messages 8 students receive on a typical day is as follows. So here's the 8 students up above, and then underneath is the number of text message that they receive. Draw a dot plot for the number of text messages received on a typical day for these 8 students. So what I want to do is I'm going to draw my line, and I'm going to start it at 35 because that's my lowest point. And I'm going to count by 5s. And I know that I need to get up to 70. And now I'm going to put dots over how many times I see these and where I see these. So my first one's going to be at 42. So I'm going to find where about 42 is. And I'll put a dot there. And then I see I have 56. So find 56. Put a dot. 35. 70, which is way out here. And that was my 4th data point. Of course it's not going to stay. Then I got 56. 50. 65. And 50. So there's my dot plot right there. Find the mean number of text messages these 8 students receive on a typical day. So what I first have to do is take all of these and add them up to find the mean. So I'll add 42, 56, 35, 70, 56, 50, 65, and 50. I'll add all of those up, and I'm going to divide it by 8. And the reason why I'm picking 8 is that's how many different data points that I have here. I have 8 numbers I'm adding up, so I got to divide it by 8 to find my mean. And when I actually get that, just for the sake of this, my mean is actually 53. And I'm not showing my work, but you are definitely going to need to. So now what I need to do is look at find the mean absolute deviation for the number of text messages and explain its meaning using words of this problem. So I'm going to find the mean absolute deviation. So I can find absolute deviation just by finding how far away each of these numbers are from 53. So I know that's 11, that's 3, that's 18. This one is 17, 3, 3, 12, and 3. So I would take all those values, and the reason why they're all positive is because it's absolute deviation. If it were regular or standard deviation, we're going to do the negatives and positives. So this one would actually be a negative if it were standard deviation because it's below, or the value is lower than my mean. This one, 70, would be positive because it's higher than my mean. But because it says absolute deviation, and that's what we're looking for, mean absolute deviation, I'm just finding how many jumps or how far away each of those values are from 53. So to find the mean absolute deviation, I take all those values and I add them up. So I have 11, 3, 18, 17, 3, 3, 12, and 3. And I can add all of those up to get my total. It's 10, 19, 25, so it's 30, 5, 6. So I get 70. And now I'm going to take that 70 and I'm going to divide it by how many data points I had. 1, 2, 3, 4, 5, 6, 7, 8. And once I do that calculation, that'll give me my mean absolute deviation. So I'll leave that calculation to you. D says describe the shape of this data distribution. If I were to plot this, it looks partly symmetrical. Because if I ran a line kind of right here on the graph, these two would match up with these two. These would kind of match up with these. It's not perfect, but it looks more symmetrical than skewed. So I'll put symmetrical in. Or symmetric. And E says, suppose that in the original data set, student 3 receives an additional 5 text messages per day, and student 4 receives 4 fewer text messages per day. Without doing any calculation, does the mean for the new data set stay the same, increase or decrease, as compared to the original? Now the first thing I need to do is I'm going to go to student 3 and I'm going to add 5. So I take that 35 and that's going to go to 40 now. And then I'm going to student 4 and taking away 5 from theirs. So it's not 70, it's 65. So the question underneath says, without doing any calculations, does the mean for the new data set stay the same? Yeah. It stays the same. So I can put yes, same. Because what we're doing is we're taking 5 away from one student and adding 5 to another student. That's not going to change the mean because when I find the mean, I add all of the text messages up. It doesn't matter who has what. I know that I'm still going to get the same. So if I add it up, 42, 56, 40, 65, 56, 50, 65, and 50, I'm going to get the same as if I added up my original numbers. And that's what matters for mean, is the total. When I add 5 and take away 5, I'm going to be left with the same value. Now, looking down below, without doing any calculations, does mean absolute deviation for the new data set stay the same? that doesn't stay the same, because I'm looking now at my blue values, and that's the distance each of those numbers are away from the mean. And I know that this is no longer the case. It's not 18 away. It's only 13 away. And my 70 is not 17 away because now it's 65. It's only 12 away. So actually, my mean absolute deviation is decreasing because the two, my lowest value and my highest value are now getting closer to the mean, which means that my mean absolute deviation is going to be smaller. So thanks for watching. Hope this helps, and good luck on the rest of your problem set.